time to get excited. As we dive deeper into contact lens, let's get clinical. In this session, we're going to take GP contact lenses clinical as we go in and talk about fluorescein patterns, things that you're going to see in clinic. We're also going to talk about different types of GP contact lens designs and when we want to use them with specific patients, right? And then we're going to finish up with flexure and warpage, things that we're going to want to think about whenever we're fitting and seeing patients with GP contact lenses. So let's take it to the text. So if you look at fluorescein patterns, the first type of fluorescein pattern we want to talk about is an alignment fit. So whenever you guys think of an alignment fit back to contact lens clinic, right? What do you guys think of? Yeah, it's like this even distribution of fluorescein, right? You don't see any pooling, you don't see any significant bearing, right? Just like everything kind of looks like uniform, right? So think of alignment fit, think like uniform, right? All the same. Let's talk about a flatter than K fit. So what's going to be your fluorescein pattern with a flatter than K fit? Yeah, you're going to see bearing in the center, right? So there's going to be touch in the center, lack of fluorescein, and you're going to see fluorescein pooling in the periphery of your contact lens. Excellent. What about a steeper than K fit? Right, with a steeper than K fit, your fluorescein pattern is going to see pooling in the center, right? And you're going to see touch around the edge and then a potential for what kind of condition? Seal off, right? Which is going to be a lack of tear exchange. Great job, guys. All right, now we're going to talk about spherical fits over a with the rule and against the rule cornea. So let's take that to the whiteboard. So if we take a spherical GP contact lens and fit it over a with the rule astigmatism, right? The fluorescein pattern that we'd expect to see would be a situation where we would see touch horizontally, right? Because we talked about the flat meridian in a with the rule cornea is going to be the horizontal meridian. So it's going to be closer in proximity to the GP contact lens, so you're going to see touch there. What's going to happen is the vertical meridian of the cornea, right, is going to have a steeper curvature than your contact lens, so you're going to see pooling vertically, right? So the key take-home message with the rule cornea, you're going to have touch horizontally, pooling of your fluorescein vertically. So now let's talk about an against the rule cornea, right? So an against the rule cornea, you're going to have the exact opposite situation, right? So an against the rule cornea, remember, we're going to have a flat meridian vertically, right? And the steep meridian is going to be horizontally, right? So what's going to happen there is you're going to see touch in the vertical aspects underneath your GP contact lens, and you'll see fluorescein pooling in the horizontal meridian. Now let's talk about some specific GP contact lens designs and when we would think about fitting them clinically, right? So whenever we think about a bitoric contact lens, right? When do we think about fitting those clinically? Yeah, it's exactly right, right? There's kind of the main two situations that we think of, right? Increased corneal astigmatism, right? So increased corneal astigmatism, and then also whenever a patient has increased residual astigmatism. Right? So two main rules when we think about a bitoric contact lens. Increased corneal astigmatism and then also increased residual astigmatism. So the back surface of the bitoric is going to match the corneal astigmatism and correct it, right? And then the front surface of the contact lens is also going to be toric, and that's going to match and correct the internal or residual astigmatism. Excellent work, guys. So let's talk about back surface torics, right? So when we want to fit a back surface toric. Back surface torics are a little bit hard to find the right patient to be able to fit, right? And that's because whenever we think about fitting a back surface toric, right, one of those rules that we think about, okay, when do we think about fitting a back surface toric? That's going to be increased corneal astigmatism, right? Just like with a bitoric, right? If somebody has increased corneal astigmatism, right, what we're thinking about is, okay, I can't fit a spherical contact lens on them anymore because it may move too much, right? And so we're going to think about fitting a toric back surface, right? But there's also this other rule that we have to remember, right? And that rule you guys will see in your text is that the magnitude of their spectacle astigmatism has to be equal to 1.5 times their corneal astigmatism, right? So their Rx, their spectacle astigmatism, right, has to be equal to 1.5 times their corneal astigmatism. Right? Now, why is this rule there, right? Let's look in the text, right? So the big picture here, now this is going to be more for background information than I think is something that's really going to be asked for on boards, but I want you guys to have it because you might be thinking like, Ryan, like why is that 1.5 rule even there? I think that's important to know for boards as you guys move forward. But the why behind it has to go into the fact that the index value of the GP contact lens, right, and the index value of the tears are different, right? So if we think about the index value for most GP contact lenses, or just an example of an index for GP contact lens would be like 1.49, right? Would be an example of a GP contact lens index. And we said the index of our tears is 1.336, okay? So because of that index difference, right, what will happen, and you guys will see this in the box here in your text, is that the back surface of a back toric lens, and the same thing's true for a bitoric lens, right? The back surface, the back toric surface will actually overcorrect the corneal astigmatism because of that index difference. So in these patients, you need to have spectacle astigmatism equal to 1.5 times the corneal astigmatism, so that extra cylinder correction, right, will perfectly correct the patient's total astigmatism, and they'll be able to see, all right? Now, if you have a situation where somebody doesn't have a spectacle astigmatism that's 1.5 times the corneal astigmatism, right? If you fit them in a back toric lens, what'll happen is that you will overcorrect their astigmatism, right? And you'll actually induce some astigmatism in their vision. They won't be able to see quite as well out of a back toric. So, all that being said, your key take-home message is 2 rules for back toric: increased corneal astigmatism, and refractive astigmatism has to equal 1.5 times the corneal astigmatism. And then your take-home clinically is back surface torics are hard to fit because it's hard to find a patient that meets those criteria. So whenever we think about a front surface toric contact lens, what are going to be our two main rules we're going to think about? Well, number one, we're going to think about, okay, they're going to be decreased corneal astigmatism. Right? Because what we're going to do is we're going to use the fact that if they have less than 2.5 diopters of corneal astigmatism, we can put a spherical back surface on the contact lens, and we can use the tear lens, right, to perfectly correct their corneal astigmatism. Now, the other rule, whenever I think about front surface toric, I think residual astigmatism, right? So they have residual or lenticular astigmatism. So in everything of front surface toric, we're going to think, okay, they're going to have less than 2.5 diopters of astigmatism, so we can correct their corneal astigmatism with the tear lens, but they have overall residual astigmatism, and so we're going to put that on the front surface of that toric, of that contact lens, to correct there. Now, what's the big problem? What makes a front surface toric really difficult to fit? Yeah, problem is rotation. Right? If that contact lens even rotates a little bit, it can actually make their vision worse than if you had just fit them in a spherical contact lens, right? And so the main problem why front surface torics are really hard to fit is going to be rotation. Now, if you look in your text, there's going to be a really nice box in your text of generic GP contact lens rules, and it's essentially what we've written here on the board in that box. So I've kind of simplified that down to kind of do some arrows here, so I'm hoping that's helpful for you guys. But if it's more helpful for you to see that box, then just highlight that box, and that's the important stuff you guys need to know as you are attacking and moving forward with your board's preparation. Let's talk about aspheric contact lenses. So the main thing to remember about aspheric lenses, right, or in general, aspheric lenses are ones where they progressively flatten towards the periphery of the lens, right? And that's going to mimic the flattening of the cornea, okay? But it doesn't change the overall prescription of the contact lens. So what is this going to allow in terms of benefits for an aspheric contact lens, right? Well, look in your text, right? They're going to be listed right there in that paragraph. So you're going to get increased alignment between the GP contact lens and your cornea. That's going to lead to increased comfort, right, with the contact lens and better centration. And then also you're going to get less aberrations with an aspheric contact lens, right? Now, what's going to be the biggest downside or potential problem with an aspheric contact lens? That's going to be exactly right. If you're mimicking the corneal flattening with your contact lens, right, then you're at a higher risk of having decreased tear exchange, right, and potential for seal off. Okay, very good. So that's going to be all there in the text. You guys will see that bolded in the text. Let's continue on and talk about multifocal GP contact lenses. So we've got mainly 2 types we're going to talk about: simultaneous design and then translating design. So simultaneous, think of this. Both the distance and near vision simultaneously go through the pupil. Right? So both your distance and near portion go through the pupil at the exact same time. So almost kind of think of it as your multifocal soft lenses, right? Or your progressive lens where you have both the distance and the near portion almost like it's invisible in the contact lens. That's going to be your simultaneous vision contact lens, right? And the key thing about your simultaneous contact lens is that you're going to have perfect, or not perfect or near perfect centration, right? Because if that contact lens decenters almost even just a little bit, it can really degrade a patient's quality of vision. Very good. Let's talk about translating design. So whenever I think about a translating design, I think of like a flat top 28 bifocal almost, right? Because it's going to be a segmented line that you're going to see on the contact lens, right? And so what's going to happen is as the patient looks down to read, the bifocal is going to, or the lens is going to move up and it's going to move into their bifocal, right? So almost just think of it, like I said, like a flat top 28 and a bifocal, all right? Very good. Let's finish up this section talking about flexure and warpage. And what's the big difference between those two? That's exactly right. Flexure occurs only on the eye, right? You take the contact lens off of the eye and it goes back to its original shape. And warpage is going to occur on the eye and off of the eye. So that's the key difference there between flexure and warpage. And I think that's your take-home message, is that difference between the two. Excellent. Now, if you look in your book, you're going to see some characteristics there. You might want to put a star next to that or kind of highlight that area. You're going to see center thickness, corneal astigmatism, optic zone diameter, contact lens material, and then lastly, base curve are all going to influence flexure and how much flexure we're going to have with a contact lens. Very good. Let's continue on. Finish up with warpage. So if you look in your text with warpage, we're going to write out to the side of that occurs on and off of the eye, right? And then what's going to be the main cause of warpage of a contact lens? Yeah, it's going to be your patients that are like, the ones that like almost cause them like a scratch on their hand. They clean their lenses so hard, right? You can almost see like a callus on the palm of their hand because they clean them so much. You're like, hey guy, it's okay. You don't have to clean it quite that hard, right? So that's going to be your key. That's going to be the number one cause of warpage on a contact lens. You guys want to highlight that in your text: excessive digital cleaning. All right, guys, you did a great job on this video. Go dominate the quiz, and I'll see you on the next one.